Today we're going to review Module 5, Triangle Relationships. The big deal with this whole section talks about triangles and how their angle's relationship with its side, or its side's relationship with its angle. If you think about it, if I have a little tiny angle right here, then the side here is going to be really little tiny because it only opens up so wide. If I have it really far open, then of course the side's got to be bigger. And that's what this whole unit is talking about, is how can we just look at the triangle and decide about its sides or its angles. So first, looking at this triangle here, let's just say we have an 80-degree angle, a 40-degree angle, and a 60-degree angle. And it says I want to order it by its sides. And when it talks about ordering it by its sides, it's got to tell you if it wants least to greatest or greatest to least. That's going to be the big deal you've got to pay attention to because it could mess you up. So I want to go least to greatest. And I want to order it by its sides. So when I do this, I need to look first. The smallest angle produces opposite of it the smallest side. I'm just going to use S for small. The medium angle, or the one in the middle, produces the one in the middle. And then the largest angle is going to produce my largest side. So now when we go back to talking about sides, remember one, they are line segments. So this side right here is my smallest, so it's side AB. Second is my medium, so it's side AC. And third is my side BC. Pretty straightforward. Pretty good. We do the same thing when we're talking about a triangle based upon its side. So let's just say that he's 3, he's 13, and he's 15. Oops, sorry. So now, if I want to order this one here by its angles, I don't have an angle measurement, right? But, again, I'm just going to do least to greatest. But, again, the sides determine the angle. So this tiny little side here right across produces that angle. So angle A is going to be my smallest. Then my medium side straight across gives me my medium angle. And then my largest side straight across gives me my largest angle. So now, when I want to order my angles from least to greatest, my smallest angle is angle A, my medium angle is angle C, and my large angle is angle B. Very common, very straightforward, so I like that. The second thing we did was talking about, hey, does a triangle exist? All right, so does it exist? Well, easy way to find out is it's going to say, all right, I have this triangle here. It's a 3, 4, and 5. Does it exist? Well, first of all, you know the inside has to be 180 degrees. Usually that's not what they're talking about, but it's good common knowledge to remember because you're going to be using that forever. 180 degrees inside of that triangle. So now, the easiest way to determine if it exists is just look at its sides. If I take the two smallest and add them together, so 3 plus 4 gives me 7. It has to be larger than this third side, which is 5. That's what the theorem says. The theorem just says that two sides have to be larger than the third, which if you take the two smallest, then if they're larger than the biggest, then every other combination ends up working. You could try all three sides and say, okay, 3 and 5 is 8, larger than 4. 4 and 5 is 9, larger than 3. But really, you only have to pick the two smallest sides, and if they're larger than the third side, we are good to go. Perfect. So you don't have to do a lot of extra work with that. And then the last one asks, hey, I've got two sides of my triangle, and I want to talk about the range of the third side. Now, the range means it's going to be values. It's always set up with something is less than the side, which is less than the other side. Be careful because These are less than signs. They will try to throw in less than and equal to confuse you in the multiple choice answer. So always look at here, they have to be a less than sign. So, given a triangle, let's say we have a 5 and a 3, and I want to know what is the range of the third side. So, easiest way to figure this out is, first, the theorem we just did. We know this third side has to be smaller than these two added together. So my question mark side has to be smaller than 5 plus 3. Why? Because remember we said these two sides added together have to be larger than the third side. So he has to be smaller. So my question mark has to be smaller than 8. That's a given. But it also has to be larger than something. And that's where the second piece comes in. It also, the question mark has to be larger than the 2 subtracted. 5 minus 3. Why? Because, well, let's just get this answer first, is 2. If this side has to be larger than 2, right? It's got to be, the question mark has to be larger than 2, but less than 8. Because remember, if it's 2, that would be 5 and it can't be equal. If it's 3, then this would be 6, and remember the 2 together have to be larger than the third. So it has to be larger than 2 and then less than 8. So how do I throw this in here? Well, this right here is written backwards in the compound inequality. Remember, if I rewrite this, the side smaller stays with the side smaller. It looks like this. So when I come back up here, 2 is less than x, which is less than 8. This is always your small number. And this is always the larger number. Because it's going to be smaller than this, and then this is going to be larger than that. So if you get confused, just know the smaller number has to come first. The second number has to come second. But also know that it is two inequalities, not... it is inequality, sorry. It's two less than symbols, not less than or equal. That's how they're going to mess you up in the thing. Good luck, and if you have any questions before your test, please get with me. I appreciate you. Bye.